हेलो एवरीवन, वेलकम टू दिस वीडियो। आज हम लोग करने जा रहे हैं एटॉमिक स्ट्रक्चर का पहला पार्ट, जो कि होने वाला है बहुत ही सिंपल, बिकॉज ये पार्ट आप लोगों ने पहले क्लास में पढ़ लिया। तो बिना कोई डिले करे शुरू करते वीडियो को, और बहुत डिटेल में मैं नहीं बताऊंगा क्योंकि आपको पता है ऑलरेडी। ठीक है, तो चलिए शुरू करते हैं। आज है हमारा एटॉमिक स्ट्रक्चर का लेक्चर 1। ठीक है, स्ट्रक्चर ऑफ एटम बोलिए, एटॉमिक स्ट्रक्चर बोलिए, चीज़ सेम है। तो हमारे फर्स्ट पार्ट ऑफ द चैप्टर में आप देखिए हमारा है कि जो फंडामेंटल पार्टिकल्स है एक एटम का, मान लेते इलेक्ट्रॉन है, प्रोटॉन है, न्यूट्रॉन है, पॉजिट्रॉन है, मिसॉन है, एंटी प्रोटॉन, एंटी इलेक्ट्रॉन, ये सारे जो चीज़ें हैं, बहुत सारी चीज़। पर हम लोग तीन के बारे में पढ़ते, प्रोटॉन, न्यूट्रॉन, इलेक्ट्रॉन, और न्यूक्लियस के बारे में भी पढ़ते। तो चल शुरू किया जाता है। इलेक्ट्रॉन किसने डिस्कवर किया, कैसे डिस्कवर किया, प्रोटॉन किसने डिस्कवर किया, कैसे डिस्कवर किया, और न्यूट्रॉन किसने किया, कैसे किया। बस ये चार चीज़ हम लोगों को पहले पार्ट में देखना है। उसके बाद न्यूक्लियस किसने डिस्कवर किया, क्या डिस्कवर किया, कैसे डिस्कवर किया, वो भी हम लोग देखेंगे। ठीक है, तो आ जाते हैं फर्स्ट टॉपिक, इलेक्ट्रॉन डिस्कवर किसने किया। इलेक्ट्रॉन डिस्कवर किया था जे जे थॉमसन ने। किसने? जे जे थॉमसन ने। तो फर्स्ट आ जाते हैं डिस्कवरी ऑफ इलेक्ट्रॉन पे। किसने किया? जे जे थॉमसन ने किया। ठीक है, उम्मीद है कि मेरी हैंडराइटिंग उतनी ज़्यादा ख़राब नहीं है। ठीक है, जे जे थॉमसन ने किया था डिस्कवरी ऑफ इलेक्ट्रॉन्स। अब उन्होंने किया कैसे कि उन्होंने एक ट्यूब लिया जिसको हम लोग बोलते हैं स्पेसिफिक डिस्चार्ज ट्यूब। ठीक है, तो उन्होंने क्या किया, उन्होंने एक डिस्चार्ज ट्यूब को ले लिया। ठीक है, कैसे दिखता है डिस्चार्ज ट्यूब? एक सिलेंडर की तरह दिखता है, कुछ ऐसा। ठीक है, कुछ ऐसा दिखता है। ठीक है, अभी मैं ड्राइंग को रफ ड्राइंग कर रहा हूँ तो अभी ठीक ठाक नहीं होगा, तो कुछ ऐसा दिखता है। तो उन्होंने ऐसा एक ट्यूब ले लिया। अभी उस ट्यूब के इधर पे एक वैक्यूम पंप होगा, यहाँ पे ऐसे एक पंप होगा जहाँ इसके अंदर मौजूद एयर को बाहर निकाल लिया जाता है। ठीक है, अब इसके अंदर हम लोग एक गैस को भर देते। ज़्यादातर यहाँ पे हाइड्रोजन को ही यूज़ किया गया था, तो अब इसके अंदर एक गैस को भर दिया गया। ठीक है, यहाँ पर एक कैथोड रख दिया गया, यहाँ पर एक एनोड रख दिया गया, इसको कनेक्ट कर दिया गया सर्किट के माध्यम से, इसको भी कनेक्ट कर दिया गया सर्किट के माध्यम से। ठीक है, तो एक जगह पे कैथोड रखा गया, एक जगह पे एनोड रखा गया। ठीक है, अब आपको पता है कि कैथोड का मतलब होता है नेगेटिव टर्मिनल और एनोड का मतलब पॉजिटिव टर्मिनल। सो ये हमारा एनोड भैया और ये हमारे कैथोड भैया। ओके, कैथोड इज नेगेटिव, एनोड इज पॉजिटिव, सो वी हैव shown that. Clear? Hopefully there is no doubt regarding this. Fine. Now what J.J. Thomson did was, J.J. Thomson made this part he has made this fluorescent. You can also say as phosphorescent or fluorescent. That means I'm writing over here fluorescent. Fluorescent. That means if some particle will strike that portion, that will start to glow, fluorescence. Clear? Due to fluorescence. So he used a fluorescent substance behind that. Right? Clear? Now what he did was he placed a gas into a discharge tube and he applied voltage, a very high voltage of 10,000 volts. Imagine, that's a very high voltage. 10,000 voltage he applied at a pressure of around 10 to the power minus 2. 10 to the power minus 2 to 10 to the power minus 3 millimeter Hg. This pressure was there and this voltage was there. In this condition, what he found was that there was a stream of particles. Now he did not see the stream of particles because electrons could not be visible with naked eye. Of course not. Right? So what he saw was that the fluorescent screen which was behind the anode started to glow. Now why did it start to glow? It can start to glow because some particle must have strike that. So therefore he came to a conclusion that there was some particle that is coming from the cathode towards the anode and causing the fluorescence. Clear or not clear? So this is what led him to this conclusion, that there was a ray which he called cathode ray because it is coming from the cathode and going towards the anode. Clear or not clear? Any doubt regarding this? Very easy part. Still I am explaining. Is it clear? Understood? तो समझ में आ गया सबको ये बात? सिंपल सी बात है. अब बुक में दिया हुआ है कि cathode ray travel in properties, right? Properties of this cathode ray that you will read from the book. I will not tell about that. Okay, I will just tell the points and I will move on because I did not discuss about it very much. Property of cathode ray straight line. How will you prove it in straight line? You can place up any object, a very small object in that path. You will find a shadow is being formed. Shadow can only form when the particles are in a straight line. So the ray must be in a straight line. Done. Second is they have kinetic energy. To prove that you can place a very small paddle, you will find a paddle starts rotating. If they had no kinetic energy, the paddle cannot rotate on its own. Can it? No. Next, if you give a magnetic field around or electric field around, you will find this cathode rays are getting deflected. They are not in a straight line. Now they have got deflected towards the positive pole. That indicates that they are negatively charged particle as well. If they are getting deflected towards the positive pole, that means they are negatively charged particles. Clear? Then fluorescence, that you have already seen. Then X-ray. X-ray. This cathode rays will produce X-ray when they will hit very heavy metals, very bulky metals. Bulky metals like you take it on tungsten, copper, all this. These are very heavy metals. So when they hit this, they will produce X-ray. X-ray is actually produced due to transition of electron. Okay, fine. Cathode rays produce heating effect as well. They can penetrate to thin sheets of aluminium. Fine. So these are the characteristics which I have got nothing to discuss about because you will just read it, theory. Right? Fine. Well, next point is the charge to mass ratio. Fine. How it is coming up, that is not required. Fine. Like the calculation is not required, but you should just know the value of charge to mass. That is E by M ratio. Okay. Let us move on with the E by M ratio. E by M ratio. Understand, first of all, E by M ratio is independent of nature of gas taken. What do I mean? In the discharge tube, if we take whatever gas, the E by M ratio is being similar. So it is not depending on what gas we have taken. Fine. So this electrons, this was later on named as electrons. So electrons is a fundamental particle. Clear? It is a fundamental particle. But when I talk about proton, you will find they are not a fundamental particle because the E by M ratio is not constant. Right? So these are fundamental particle. Clear? Fundamental particle, universal particle means the same. Fine. Now what is the mass of an electron, which you will even need 1000 times. Okay, you will need 1000 times the mass of electron. Fine. This you need to memorize. The mass of electron is 9.1 into 10 to the power minus 31 kg. If we want to take it to grams, according to rules, we will take it, right? 10 to the minus 20. Then, fine, clear. Next comes the charge on electron. The charge on electron is 1.606 into 10 to the power minus 19 coulomb. Fine. 1.6 more or less. Fine. Clear or not clear? This was determined by Mulliken. Mulliken's oil drop experiment is in class 12 physics again. We will be reading only there. So it is 1.6. Let us take 6 only because I am not sure it is 6.06 only. Let's take 6.6 only. I think it is 1.602. 1.602. I'm not sure, so I'm not writing it. 1.6. Fine. Mulliken has actually found out this in terms of ESU. We have converted it to coulomb. Fine. Coming to the charge by mass ratio, the E by M ratio is coming out to be E by M ratio. Even if you do not remember it, you have the mass, you have the charge. What else do you want? Simply do it. Fine. So that will come out to be 1.759 into 10 to the power 18. Fine. So it is E by M. So coulomb. Clear? This is in gram. We have taken that as minus 28. If you are taking it in kg, then we will have coulomb per kg. Fine. This answer is in gram, so it is coulomb per gram I have written. Clear? So this is the thing you need to read from discovery of electrons. Fine. Main thing is that what is the how was electrons discovered, from which direction to which direction they go, why is the name, properties. Done. Fine. Nothing else you need to read from this. Fine. Okay. Fine. Acha, hopefully you know that electron's mass is 1 by 1837 that of hydrogen atom or that of proton. Fine. Okay. Next, I am coming to discovery of proton. Discovery of proton. Fine. Discovery of proton. Who discovered proton? Eugene Goldstein. Right? Eugene Goldstein. Eugene Goldstein discovered proton by using the same discharge tube, but here he twisted few things. He made few things different. Whatever Thomson has done, he has made a few things different from that. What? Like he has changed the pressure, like he has changed the perforated anode to perforated cathode. Clear? Understood? So he decreased the pressure a little bit. Pressure to little bit decreased. ठीक है, और क्या किया था उन्होंने, कैथोड को परफोरेटेड बना दिया. ओके, सो परफोरेटेड कैथोड वाज यूज्ड. परफोरेटेड कैथोड. Right? Perforated cathode. Now fluorescent screen was placed behind the cathode. So what he saw, that started glowing. How did that started glowing? That to cathode ray was not that side. Then there must be some other ray which is traveling in an opposite direction to the cathode ray. That was named as anode ray, canal ray, or positive ray, because they are moving from anode to cathode. Clear or not clear? They are coming from the anode, that is a positive side, positive ray. Clear or not clear? Fine. Done. Next, second part is property that we will be reading. I am not saying anything. Property, same, more or less same properties will come. Deflection, straight line, deflection will come. Charge to mass ratio I will talk it. I'll tell it. Fluorescence, they are also done. Fine. Clear or not clear? Any doubt? See, it will not take much time for me to tell about this. Very small part is there. Okay. Done regarding this. Can I move on? Okay, fine. Next one that is coming up is the discovery of what discovery I'm telling. First of all, let me tell you about the masses and all. Okay, the mass of proton. The mass of proton is slightly less than that of neutron, if you remember. Slightly less than neutron. That is 1.7 approximately. In reality, it is 1.672 into 10 to the power minus 24 gram. Fine. Clear? This is the mass actually. Clear? Understood? No doubt regarding this? Acha. Electron has a negative charge, so do not forget to put this negative charge. I did not write it, does not mean you will not put a negative charge. Hopefully you know that much. Okay. Here, if I write the charge, then that will become plus 1.6 into 10 to the power minus 19 coulomb. Only the magnitude is plus. The magnitude is not minus. Fine, clear? Fine. Again, here there will be an E by M ratio, but I cannot write the E by M ratio. Why? Because it is dependent on the nature of gas taken. It is depending on the nature of gas. Dependent. E by M ratio dependent on nature of gas. Dependent of nature of gas. Now, why it is dependent on nature of gas? Arey Baba, every gas is having different atomic number, so number of proton will vary. So it will depend on that. Clear or clear? Fine. Understood? So E by M ratio will be dependent on the nature of gas we have taken. So it will be changing. Fine. Done. So I cannot give a specific E by M ratio for this. Fine. Next I will talk about discovery of neutrons. Now you see, discovery of neutron was done in a very different way. Okay, because I cannot use the discharge tube to get this neutrons existence, right? Why? Because I cannot make it deflected towards anything, right? How will I make it? Because it is neither going from cathode to anode nor anode to cathode. It is not a charged particle. Then I cannot discover it using that. So what Chadwick did was, James Chadwick, he discovered it by artificial transmutation. Now what is transmutation? You have learnt in nuclear physics. Discovery of neutron was done by artificial transmutation. Artificial transmutation. Now what is transmutation? Transmutation means bombarding one nucleus with the another nucleus. Okay, bombarding one nucleus by another nucleus. Clear? So what bombarding was done? Beryllium. Fine. Beryllium bombarding was done by alpha particle. Hopefully you know what is an alpha particle. So upon that there was a formation of carbon, which was 12. This mass number increased by 4. Should have been increased by 4 but not increased by 4. I'm telling you why. To conserve energy. Fine. 9 plus 4 was 13, so 12, and 4 plus 2 was 6. Done. Along with this there was a chargeless particle that was actually going to come up, a chargeless particle that was called neutron. This was the chargeless particle. Here comes the discovery of neutron. Fine. The mass of neutron is slightly greater than that of a proton. Okay, slightly greater. So mass of a neutron, mass of proton was 1.672, right? This 672. This is 1.675. Clear? Very slightly greater. I'm telling you, very slightly greater. Fine. 1.675 into 10 to the power minus 24 gram. Charge is 0, or I will say rather chargeless. Fine. E by M ratio. Calculate. Fine. Clear or not clear? Very easy thing. Very easy thing. No difficult. Fine. Can I get a charge by E by M ratio? 0. If charge is 0, how can E by M ratio come? Fine. So these are the discovery of 3 particles. Now properties, you will write electrically neutral, then you will write highly penetrating, and you will write cannot ionize a gas. Fine. It will not ionize a gas. That is why we cannot detect it. They will not ionize a gas. If they are not ionizing a gas, how can we detect them in a discharge tube experiment? Clear or not clear? So these are the 3 subatomic particles that discovery up to study in this chapter. Fine. Clear or not clear?